All right, welcome everybody. We're on 11.1 graphing from Intercept Form. So everything we've done so far is in standard form. We're going to get into one of the different forms. So there's two others. There's Intercept Form and Vertex Form. Intercept Form sometimes is called factored form because if you look at it, it looks like it's been factored. And that's what you would do if we needed to go from standard form to intercept form, is we would factor, and thus that's why we call it factored form sometimes. I think I will always call it intercept form though. All right, so A does the same thing that it's always done in standard form. It tells us if it goes up or down. For this class, A will always either be 1 or -1, but again in the future it could be more than 1, like 2 or 3. Okay. And then P and Q, those are also numbers. And the really great thing about intercept form is that you can easily find the X-intercepts. That's why it's called intercept form. Okay? All right. One thing that you need to, or one way that's helpful to remember what the X-intercepts are, is you just need to remember that X's tell lies. Okay, so if we look at this first parenthesis, we have x minus p, where the x-intercept, okay, one of them is going to give us a positive p, comma 0. And then the other, so that comes from here, oops, didn't point that to the right direction, and then our others would be q, comma 0. Okay, so it looks like it's a negative q, but when we take it out, it's going to become a positive. So that's why we kind of say x's tell lies. So in this situation, if we want to find our x-intercepts, one is going to be a -2, comma 0. Again, it's the opposite of what you'd think. X's tell lies. And then the other would be, what do you think? It would be a positive 9, comma 0. Okay. All right. Here's another example. Here we have where A is a negative, but it's not going to affect whether, or like it won't affect your x-intercepts. So x-intercepts will still, for this one, would be 1, comma 0 and 4, comma 0. Again, the A, that just tells us if it's opening up or opening down. All right. So why don't you give this one a try? This one's actually a little different than maybe what you'd expect. We have one parenthesis, we have this 6, so we'd have like a -6, comma 0, that's 1. Okay, now, and this was like maybe your Q minus, or X minus Q kind of thing. Where's our P? Where's our other number? Well, again, this we could rewrite this as X like plus 0 and x plus 6. Okay, so maybe that's a good idea to always write it so that there's two parentheses. That way you don't forget that one of our other parentheses from here would be 0, comma 0. Okay? All right, so get that again. So make sure we got this. So we're missing that, I guess that P. If we look at the form up here, it's x minus p, but here we just have an x, so the p must be 0, okay? And then you just do the same thing. All right, so once you've found those x-intercepts of the function, it's easy to find the vertex. So let's talk about, we'll just write down some steps on how to do this, okay? But the first thing that we need to do is to locate and plot the x-intercepts. So this is like our first step, is we need to locate, just like we did above, locate, and then we want to plot the x-intercepts. Okay, so if we look at this example, what are our x-intercepts? Again, x's tell lies, so we have a 4, comma 0, and then here we have a -2, comma 0. So we're going to want to plot those. That's our first step, is to locate and plot those. So we have 4, comma 0 and -2, comma 0. Okay? okay with that. And then our next step, what we need to do is we want to locate the axis of symmetry. Or I'll write that out. The axis of symmetry, okay? Which is halfway between the X-intercepts, okay? So if you look at this, if we look halfway between, so if we went 1, 2, 3, and 1, 2, 3, this would be our axis of symmetry. So we can find the axis of symmetry by just looking at the graph. Another way you could do that, and I don't think I'll be doing it this way, but you could also average the two, the P and Q. So if you did like 4 plus a negative 2 divided by 2, this is like averaging them, you'd end up getting 1. So either way, but I probably shouldn't talk about that because that's just one other thing to be worried about. So don't worry about that. Okay, so we found our axis of symmetry. So we plotted the x-intercepts. We located the axis of symmetry, which is halfway between the 2 points. Okay, and so our axis of symmetry here, x is equal to 1. Okay, and now we're back to where we were before with standard form. If we have an x and we need to find a y, okay, all we need to do is plug x into the equation and solve for y. Okay, so and this gives you your, yeah, so this is like x equals the axis of symmetry. So that gives you your x and that gives you your y, and now we have our final thing is our vertex, which here is x comma y. So here if we go back to this one, we have our x, we need to find our y. Maybe I'll do it over on this side. So we'd have y is equal to x. Well, x is 1, so we'll do 1 minus 4, and then we'll do 1 plus 2. This gives us negative 3 and 3, and we end up getting negative 9. So this gives us our y for our vertex. So we've got 1 comma negative 9. So our vertex is right here. And then we'll use our growth pattern. So again, the A is in front of the parenthesis here. So here A is 1. And that means we're going to go up. Over 1, up 1, over 1, up 3, over 1, up 5. Check. We already have that point. And we'll do it on the other side too. Over 1, up 1, over 1, up 3, over 1, up 5. Check. That one's there as well. So we'll connect those dots. So like when we did standard form, the constant helped us to double check our answer. It would give us our y-intercept. When we do intercept form, those x-intercepts will check and make sure that we have it in the right spot. All right, so let's recap this up. So we locate and plot the x-intercepts. Again, x is tell lies, so when we take those out, they're going to be their opposite signs. We plot those x-intercepts. Our second step is to find our axis of symmetry, which is halfway between those x-intercepts, because parabolas are symmetric. And we find that x is equal to 1. That's our axis of symmetry. And then to find the y, we plug that in to our equation. We get negative 9. So our vertex is 1, negative 9. We plot that. We'll use our growth pattern, 1, 3, 5. All right, we'll do a couple more examples. I'll probably try and go a little quicker. You're welcome to do the problem and then skip to the answer. Just looking at it, we probably should definitely look at B, because that one's a little tricky. And then there's just a couple more examples where we do the key features, and then I think that's it. So we'd also probably want to talk about E. So definitely before you leave, go over those two, okay? All right, so here we go. We have our x-intercepts. Again, x's tell lies, so we have -2, 0, and -6, 0. We'll plot those. Axis of symmetry is halfway between, so that would be right here. All right, so that axis of symmetry is x equals -4. And then we need to find our y by plugging that in. So we have negative, and then we have -4 plus 2, and then we'll do -4 plus 6. All right, we'll simplify that. You can use your calculator, but we'll get negative already, and that will give us a -2 and a +2. When you do these, if you have the right axis of symmetry and you plug it in, your two numbers should be the same, just their signs are different. Okay, so that's always something you can look at that. Okay, so here we'll end up getting 4. So our vertex is -4, 4. Okay, we'll use our growth pattern, over 1, up 1. Sorry, I did that bad. Okay, it's -4, 4, which is up here. A is negative, so we're going to go down. And over 1, down 1, over 1, down 3, over 1, down 5 on both sides. And we've got it. Okay? All right, B, we needed to talk about that. So again, this is kind of like when we have the x plus 0 and x minus 4. So the x-intercepts are going to give us 0, 0, and 4, 0. Again, x is tell lies. It's the opposite of what you'd think. Okay? Plot those. Axis of symmetry is halfway between, so that would be x equals 2. And then y is equal to, we plug that 2 in, and here we get 2 times -2, which is -4. Growth pattern goes up, over 1, up 1, over 1, up 3, over 1, up 5. Both sides, connect the dots. Okay. All right, here's just a couple more examples. Again, x-intercepts, we've got 1, 0, -3, 0, x's tell lies, opposite of what you'd think. So we plot those, 1 and -3. Axis of symmetry is going to be halfway between, so that would be x equals -1. This is the axis of symmetry. Y is equal to, again, we substitute the x in. Okay, so we end up getting negative, and then here we'll get -2, and then a +2. That gives us 4. I think we did one very similar to that. All right, plot those. So our vertex is -1, 4. We use our growth pattern. A is negative, which means we're going to go down. A lot of these problems are very similar because they, in order to do these equations, they have to have a nice x-intercept. When we talked about standard form, the x-intercepts didn't have to be like a very good spot, but these ones have to end up pretty good. So a lot of your problems, a lot of them will be similar. Okay, we can write down our x-intercepts. We actually wrote those down already. So 1, 0, and -3, 0. Y-intercept is 0, 3. Axis of symmetry, we found that too. That's x equals -1. Vertex, we already found that, which is -1, 4. Okay, is the vertex a max or a minimum? It's a max, and its value here is 4. Again, it's always your y for your vertex, and the direction of opening is down. Okay, Again, we still want to do E, so make sure you go to that point, at least watch that part. All right, so here's another one, our X-intercepts, because we could just write them over here. We have -1, 0 and -5, 0. So we'll plot those. Axis of symmetry is halfway between, so that would give us an axis of symmetry of x equals -3. So we'll do that here, x equals -3. We need to find the y, so we need to plug that into our equation. So -3 plus 1 and -3 plus 5. That gives us -2 and a +2. See what I'm saying? A lot of these are like very similar when we end up getting to that point. So here we get -4. Growth pattern goes up. Sorry about that. Hopefully nobody comes in yet. And there we go. So we could write down our y-intercept. It looks like, kind of missed that a bit, is 0, 5. Vertex, we said, was -3, -4. It has a minimum value of -4, and it opens up. Okay, so we need to talk about this last one. Again, an exponent tells us that we're multiplying the base by itself twice. Okay, that's what squared means, really. Okay, so we need to write this something like this. All right, now we could find our x-intercepts. So we'd have, again, x is tail i's, so we'd get 2, 0 and 2, 0. So they're the same. We don't need to write both of them. So just 2, 0. If you wrote both of them, it's fine. I wouldn't take points off, okay? So we have that, 2, 0. And then here, usually we find our x-intercepts like by finding what's between those two. But since they're the same, okay, that means our axis of symmetry is at that same point. Okay? And then our y would plug that into our equation. We could plug it into either the original or this one. Either way would be good. Why don't we do this one? So 2 minus 2 times 2 minus 2, that's 0 times 0, which is 0. So our vertex here is 2, 0. And then we'll use our growth pattern. Since A is positive, we'll go over 1, up 1, over 1, up 3. Okay, so this is what it looks like when you have something like that, okay? We can finish this up. For y-intercept, looks like we got 0, 4. The axis of symmetry, we already got that, x equals 2. The vertex is the same as the x-intercept. We have a minimum value of 0, so again, it's like we're going on a hike or something, and we're getting lower and lower and lower until we get to 0. Okay, it's always based off of your y value for your vertex. And then the direction of opening is up. All right, well, if you have any questions, let me know. Again, make sure you got this written down. Again, that's our steps on how we do that. Please refer to the problems that we did together. And if you have questions, let me know. All right, we'll see you guys.